Problems like this, tough. People are having a little trouble with these. I can understand why. Okay, so what do we do with these? Now, if we've got, they're giving us some conditions here. We got triangle ABC. We want this triangle to be obtuse, right? They're telling us we've got to find out what are the conditions for side AC. It's got to be what's its lower limit for its length and the upper limit for its length if it's going to be obtuse. What are they telling us? Well, they're telling us that side AB is 77, side BC is 85, and side AC is less than side AB. So it's going to be the shortest side in the triangle for sure, right? That's one thing we know. So when I draw this triangle, here's where I think people sometimes this is going south on. You want to draw a right triangle. Okay, it's important that you draw a right triangle because that's going to be the boundary between acute and obtuse. And if we want this to be obtuse, the smallest obtuse angle is going to be one that's just a tiny bit bigger than 90, right? So we're just going to barely nudge this thing from a right triangle to make it obtuse. So when we draw a right triangle, we got something like that. Oops. Okay, let's call, this is going to be the longest side, so let's call this BC, and that's going to be A. BC has a length of 85, AB has a length of 77, and AC is the one, that's going to be our rubber band, right? That's the one that we're going to call X. We're going to either stretch that or shrink it from its right angle length to make this thing obtuse. Kind of the hard part, though, is just to determine, do I stretch it or shrink it? Which one do I do? If I, and here's how, this will really help, though, I think. If I stretch it or shrink it, now I know that the blue sides, their lengths are fixed. They can't shrink or grow, right? Only the rubber band can be stretched or shrunk. So my hinge is right there, okay? Now, if I were to let this piece, let's say we broke the rubber band and I'm just going to swing this piece around, this long piece. What kind of a path would that point C describe as I swing this around? Here's. Okay, it's going to be a circle, isn't it? Right? If I let this thing swing, isn't it just going to do something like this? If I track the point C, isn't it just kind of going to go like that? Right, if I let it swing around. Does that make sense? Okay. So all we really need to do here is just ask ourselves, if that big piece swings around, if I'm going to, for example, stretch or shrink the rubber band, which part of the circle, let's get all the phones and stuff put away. I just hate looking out there and seeing people looking at other stuff. Okay. So if I'm gonna grow or stretch or shrink the rubber band, where would it be on that circle? If I'm going to shrink it, for example, would it be up here? No, that's going to have to be stretched to go up there, isn't it? Right? If I stretch the rubber band, because this 85 is fixed, the 85 is going to swing up with it, right? So that's not going to work. If I stretch the rubber band, I get a picture like that. Oops. I get a picture like this, don't I? Right, and that's going to be acute, because look what it did to that angle. This angle down here that used to be 90 now has gotten smaller, and so it's acute, right? So we would do the opposite. So let's undo that one. That was wrong. If I, oops, there we go. So if I shrink it, it's going to be down there, isn't it? It's going to end up being down on this part of the arc when I swing this thing. And that makes sense, because then this 85 length segment would just start there and end there, right? Does that make sense? If I shrunk the rubber band, it couldn't end up here, could it? Because that would force this one to change. See what I'm saying? If I shrunk the rubber band, this picture wouldn't make any sense, right? Because the distance from here to there is not 85 anymore, right? That doesn't work. If I shrink it, it's got to end up down here. Okay, that's, you know, if you think that that's not very clear, I don't know another way to describe it. You almost have to, there is no formula or there's no rule. You just have to think about every case individually and just kind of look at it and think about it. And it's good training. It's really good to get your brain to think about what happens when I tweak a system. If I tweak a system, how is that going to impact all the parts of the system? That's really valuable to be able to kind of train yourself to do that a little bit. So that's the good news. It's just sort of awkward and not easy, though. That's, I guess, the bad news, at least when you first start doing it. It does get easier, though. Okay, yeah, we'll get to that. So then, if we know that we've got to shrink the rubber band to make this angle grow bigger and make this triangle obtuse, agreed with that? Right. So that's the hard part. That's what we've established so far. So if that's the case, then when we set up our inequality up here, x is greater than something and less than something, what's going to be the number at the top? Well, we got to figure it out. We've got to figure it out. So let's get rid of those pieces. How is it Friday? Oh, nothing's working. Okay, so what is x going to be? How do I figure out what this length would be for it to be a right triangle? Because it's got to be a little bit less than that, doesn't it? We have to shrink it from that length. How would I figure that out? Pythagorean theorem, right? Does that make sense? This is a right angle. And so I can just set up the Pythagorean theorem and say x squared plus 77 squared equals 85 squared, right? A squared plus b squared equals c squared, where c has to be the hypotenuse. So if I do those numbers, I'm going to get, somebody got a calculator, they can help me out here. What is it? What is that going to be? I don't want to figure it out. It's for 62, something 29. I don't know, we'll see. I don't know what it is. I don't want to think about it right now. $59.29. Equals 85 squared. Don't want to think about that either. 72.25. If I just make those into big numbers, now what do I do?
Oh,
No, what am I going to do? I'm going to solve for x here. Okay, good. Subtract. There. There we go. Okay, good. So if we do that, we get x squared equals, let's see, we can do this quickly. Oops. 1296. And the square root of that, anybody know?
Oh, like
36. Okay. So that's going to be, that's the exact length for a right triangle. So then what do we know about this? If we want to make this thing obtuse, we have to shrink the rubber band a little bit. So x has to be less than 36, right? The number that we get from the Pythagorean theorem. Okay, but the other question is, what's going to be this lower limit down here? What's going to go there? Now, this is the part where we've got to remember back to the triangle inequality from a long time ago. Okay, the triangle inequality is the one that says, if I've got a triangle, I know that the shortest two sides have to add up to a number always that's bigger than the longest side, or the triangle wouldn't work, right? These sides wouldn't be big enough to touch in the triangle, right? So that tells us that x plus 8 has to be bigger than 12 So if I subtract 8 from both sides, x has to be bigger than 4 in this case, right? So for our triangle, let's see, we got 77 and x and 85. So what has to be true in our triangle? If we shrink x way down, still something has to be true. X plus what has to be greater than what? Yeah, good. X plus the other short side, 77, still has to be bigger than, combined, has to be bigger than the longest side. So if I subtract 77, I just get x is greater than 8. Make sense?
Yeah.
Okay, so that's what goes there. So that's my answer, right? Instead of x, we're calling it AC, but that other segment, the rubber band, has to be greater than 8 in length and less than 36 for this to be an obtuse triangle. Okay, make sense?
Yeah.
If it were going to be acute, we would have stretched it instead of shrunk it, and it would have been greater than 36 and less than 77, right? Because they're telling us that AC in this case is less than 77, less than AB, right? So then we would have had a 36 here and a 77 there, right? Different conditions. Okay? Those are not easy, I admit. They take a little thinking, but thinking is good. Oh yes. Even on a Friday, thinking is good.